Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to go through question number 6 from the October-November 2021, the International A-Level Cambridge Pure Mathematics P1 paper. This is from AS paper 9709. And we have a question here which is dealing with radian measure. It says the diagram shows a metal plate ABC, in which the sides are the straight line AB, the arcs AC and ABC. The line AB has a length of 6 centimeters. The arc AC is part of a circle with center B, all right, and radius 6 centimeters. And the arc BC is part of a circle with center A and radius 6 centimeters. So if I just draw a line here just to make this clear, I'm going to draw a line joining B and C together. Okay, so, and also joining A and C together. Right? So these two lines are both 6 centimeters. And this is the arc BC with center A, and this is the arc AC with center B. So we have an equilateral triangle. So these angles are all the same angles. In terms of degrees, it's 60 degrees. 60 degrees is equal to change degrees into radians, okay, you multiply by pi over 180. Okay, so 60 degrees is going to be, that's going to be pi over 3 radians. Okay, 180 degrees is 180 degrees is pi radians, pi over 360 degrees. That's right. That's going to be pi over 3 radians. So this is pi over 3, and this is also pi over 3 because it's an equilateral triangle. These three sides are both all the same. Okay, now it says find the perimeter of the plate, giving you an answer in terms of pi. So the perimeter of the plate will simply be the length of the AB. So we got AB plus the length of the arc AC, so the length of the arc AC plus the length of the arc BC. So this is the length of the arc AC and this is the length of the arc BC. And we know that the length of an arc is given by the formula when we're dealing with radians, r times theta, where theta is in radians. So it's simply the area, the perimeter of the plate is going to be AB, which is 6, plus, and you have r, which is 6 times pi over 3 plus another 6 times pi over 3. Both the same length, those arcs. So we end up with 6 plus 2 pi, 6 plus 2 pi, plus another 2 pi. Okay, so it's going to be 6 plus 4 pi. So there's the answer in centimeters for part A. That's the perimeter of the plate, giving you an answer in terms of pi. Now part B, I'll do it on the next page. And in fact, we'll take the same diagram that we made. Okay, so now for part B, we have the diagram here that we were using in part A, will help us for part B. It says find the area of the plate, giving you an answer in terms of pi and root 3. So in exact form. So what we see is in this plate, if I just look at it a bit more closely, we have basically, if you think about it, we have the area of, let's say, the segment A, so the sector ACB, okay, plus this segment. Okay, so we can say that if you find the area of the whole sector, which is like the pizza slice, you can say CAB, okay, plus the area of the segment AC, okay, this segment here, that will give us the area of the whole plate, all right? So the area of the sector CAB is going to be, as we know, the area of a sector is a half r squared theta. That's for a sector. And the area of a segment is given by the area of the sector minus the area of the triangle. So it's going to be a half r squared theta, that's the area of the sector, minus sine theta, the area of the triangle. Half r squared sine theta, That gives us the formula for the area of a segment. For the sector CAB, we're going to have a half times r squared, which is 6 squared, times pi over 3. Plus the area of the segment here that's shaded, that's going to be a half times r squared, which is 6 squared, times, and we're going to have theta, which is pi over 3, minus sine theta, which is sine of pi over 3. Okay, that should give us the area that we're looking for. So that's going to be a half times 36. That's going to be 18. 18 divided by 3 is 6, so that's 6 pi. Okay, that's going to be 36 over 6. And that's going to be 36 over 2, which is 18, times, and you've got pi over 3, minus, now that's a sine of 60, which is root 3 over 2. Root 3 over 2, sine of 60 degrees, sine of pi over 3. Okay, so now we want to give the answer in terms of pi and root 3. So we can just simplify this. Let's expand that bracket. So 6 pi plus that's going to be 18 pi over 3, which is, again, another 6 pi, minus 18 times root 3 over 2, which is 9 times root 3. Minus 9 times root 3. Okay, because that 2 and the 18 will cancel out when you expand that. So we got 12 pi minus 9 times root 3. And there we have the answer in centimeters squared. 12 pi times 9 minus 9 times root 3, giving you an answer in terms of pi and root 3. So that's fine. And there's the answer to part B of this question. Okay, so for other questions from this particular paper, we can click on the playlist that will appear on the top right of the screen at the end of this video. Okay, and those questions will be the other questions in this paper. Other questions from my endotopic worksheet on circular measure or radian measure, you can find in the playlist down here. This question is actually taken from, or this question is used in my worksheet for radian measure, and you find the other questions that I've used in the playlist at the bottom right of the screen, and other questions from that I've answered on radian measure from P1 of Cambridge, you'll find in the playlist here. And you can subscribe to my channel by clicking the link that appears on the top left here. Thank you for watching and see you soon.